Hello everyone, welcome to section working with stream and lambda expressions. Topic: use Java streams to filter, transform and process data. Please watch my video till the end. If you like my video, give thumbs up and click the bell icon to subscribe to my channel for the latest updates. Stream. A stream in Java is a sequence of data. Stream can be used only once. There are two types of stream: finite, it has a limit; infinite, there is no limit. Lazy evaluation, which is also called as delay execution until necessary. With a stream, the data is not generated upfront. It is created when needed. We pass the lambda expression method reference in the function, and processor calls the method at its own. So let me explain this one through an example. I have created a project stream in IntelliJ and created a class eager versus lazy evaluation. Let's make a method public static boolean compute string str, and let's print something executing and this is statement return. For instance, letter A. Another method eager match. This method has two parameters, boolean b1 and boolean b2. It is going to return if boolean 1 and boolean 2 are true, then match, otherwise incompatible. Let's make another method lazy match. And it also has two parameters, supplier boolean and supplier boolean b. This returns if A and B value is true, then match, and if not match, then incompatible. I'm gonna call eager match, and then I'm going to call compute method, put BB inside, and then again compute method, put AA inside. So let's run this one. So result is executing, and incompatible. What it happens, the eager match first call compute, and it says executing, and the first method returns false, and for AA it returns true. When it goes here false and true, it returns incompatible. So for the both method calls, the class has executed the first line. Let's see the same thing with lambda expression. So if I say lazy match, as we know it is supplier, so what would be the result? There's only one executing and then incompatible. So what happens exactly? In the lazy match, we pass the lambda expression in the function or the method, but it has not executed until it's needed. So when it comes over here lazy match and we say a.get, so a.get, it went there and get the false, and it is a short circuit operator. One is false, it won't gonna execute the other one, and given the value incompatible. We have seen in eager there are two method calls, and in lazy there is only one method call, and method call is not over here in the lambda expression, which we call as declaration. It's only happen at execution. That's why we have only one executing, not like 2 times executing. So in lazy execution, data is not generated upfront, it is created when it's needed. Stream in function programming is not same as stream in input output. So remember that they are using the same word stream, but stream in functional programming is different than the stream in input and output. Stream pipeline. A stream pipeline consists of the operation that run on a stream to produce a result. The stream pipeline consists of 3 parts. Number 1, source, which means where the stream comes from. Intermediate operation, transform the stream into another one. They can be as few or as many intermediate operations as you would like. Since stream use lazy evolution, the intermediate operation do not run until the terminal operation is encountered. Terminal operation, it produces result. Once it has been run, the stream cannot be used again. The stream is no longer valid after a terminal operation completes. So if no terminal operation is in the pipeline, a stream returns without execution. So intermediate operations are chaining methods. Those return the stream. And if you do not mention any terminal operation, so it returns the stream. Intermediate versus terminal operation. Scenario: required part of useful pipeline. Intermediate, as I said, you can define or do not define. It's not required to define intermediate operation. Terminal operation, yes, you have to define to produce the result. Can exist multiple in the pipeline. Intermediates can be none, one, or many. Terminal operation, always one. Return types is a stream type. Intermediate operations have stream type because these are chaining methods. So you can call the another method of a stream. Terminal operation, they do not return the stream type. Some return void, and there is a method called count return int. Stream valid after calls, yes, because it is the intermediate operation returns stream, and terminal operation, no. There are some methods of stream. Let's see them. I have created a class myStream. Let's create some finite streams. This is the way we create empty stream. Control Alt V. Right? So how many elements inside? 0. Let's create a stream of 1 element. And call that single element. Now let's create a stream of 3 elements. And call it from array. Okay. And it has 3 elements. What about if I print the stream? This is a different from a collection where you can see the content. So this is not a useful data. It is an anonymous inner class, and this is a hash code. Let's make some collection to stream. If I create list dot of A, B, C, and call this one as list, and then create a stream from collection and call it from list. Okay, we can change any collection into stream. If we have a lot of a data, so it is advisable, instead of creating a single stream, we create a parallel stream for parallel processing. So how do we do list dot parallel stream, Control Alt V, and I call it from list parallel. Okay, now create some infinite stream, and if I say stream dot generate, and in the math class a function is random, so call it randoms, and if I do randoms dot for each, and for each returns void, and I do system dot out println, because we know the for each has a consumer, so it will give an infinite stream. See, so you have to stop it. Let's create another infinite stream. Stream dot is another method, iterate. In iterate, you need to define seed, which is called as starting value, and then unary operator, which means that what to do to get next value. So we say n plus 2. And Control Alt V. I say odd numbers and odd numbers dot for each system dot out println, and it creates infinite stream. Okay, let's comment out this one, and there is another overloaded method of iterate, in which you pass starting value, a predicate, and unary operation. So predicate is a condition. We say the starting value is 1. We pass the condition that any value would be less than 100, and whatever we put, we add 2 to it, and we say this one odd number under 100. Alright, so this one wouldn't be an infinite stream. So if I do odd number under 100 dot for each, and here I put consumer. So stopped at 99. Okay. So here we can see that we have seen empty to create stream with 0 element, of create a stream with elements listed. We put 1 and then 1 2 3. Collection.stream, create stream from collection, could be list, set. We can also make a parallel stream. So create stream from a collection where the stream can run in parallel. Parallel means divide a task into multiple processors and run parallelly. It is faster as compared to stream, especially on huge data. Stream.generate, create stream by calling the supplier for each element upon request. As you have seen, we pass the math.random. Iterate, have two methods. We put starting value, which is seed, and the unary operator to get next value. The second overloaded method, we can pass a predicate. If the predicate specify when it is done, then it is finite, and it creates a stream by using the seed for the first element and then calling the unary operator for each subsequent elements upon request. Stop if predicate returns false. If the predicate doesn't return false, it won't stop. Common terminal operations. Terminal methods are used for common terminal operations. We will see a few of them. The first one is count. Count method determines the number of elements in a finite stream. So what happens if we use them with infinite stream? It doesn't terminate. It returns long value. It is a reduction method, which means that it looks at each element in the stream and return a single value. It is pretty much like this. Okay. So I have created one class, terminal operations, and I am going to use each terminal methods. The first one is count. I'm going to create a variable count. I'm going to say stream dot of monkey, gorilla, bono, bo, dot count, and print the number of elements in the stream, and it gives 3. Next, min and max. The min and max methods allow you to pass a custom comparator and find the smallest or largest value in a finite stream as per sort order. So if you use them with a finite stream, they do not terminate. They return optional and they are reduction. So you can see the signature like this. Let's try. So stream dot of monkey, ape, bonobo dot min. Here you need to pass a comparator. I'm going to say S1 and S2, two variables, two parameters, and s1 dot length minus s2 dot length. So we are going to compare the length. Negative means smaller, 0 means equal, and positive means greater. And they return optional. There is a method if present in the optional, and I'm going to use system.out and passing a method reference of print method in system.out. So run this program. So they have given ape. So the minimum one is ape. Let's do with some other example. Boolean present equals to stream dot empty dot min s1 s2 and return 0 if it is empty, and dot is present. Then as the method is present, what it does, if a value is present, return true, otherwise false. S out, present. Okay. So it returns false because the stream is empty. Next is find any and find first. These methods return an element of a stream unless stream is empty. If the stream is empty, they return an empty optional. Okay. So if we use them with infinite stream, they terminates, return values optional, and they are not reduction. And this is a signature. Let's see them. Find any and find first. Dot find any dot if present, then method reference of println. So yes, so it has given the first one, right? If we use with the infinite stream, so what would happen? So this will create an infinite stream, and if I say find any dot if present, so this will give only one string. So find any and find first work with infinite streams. Next is all match, any match, none match. These methods search a stream and return information about how the stream related to the predicate. So if we see their signatures, so the argument is a predicate and they return Boolean. They sometimes terminate if we use them with infinite stream, return the Boolean, and they are not reduction. Do not check each value in the stream. So let's see. So all match any match and none match. I'm going to create a list. List of string. And then I'm creating an infinite stream of string. As I did earlier, generate, and I'm going to use a predicate of string. And check the first letter is a character or not. Okay. So this dot stream dot any match predicate, and we're gonna do with all match and none match. And this list is finite stream. Let's do one with infinite stream. To see that do they work with infinite or not. And let's run. So it comes true, false, false, true. So any match, yes, you can see that the first one and the third one have a character. All match, no, because the second one is a number, should be false. None match, so first and third match, so none match would be false. And infinite, any match, so all these are strings, so it says true. So it works with the finite and infinite. For each. So for each returns void, we pass consumer and it iterates over elements of stream. If you use with the infinite stream, it doesn't terminate and it is not a reduction. Let's see. For each and stream dot of monkey, gorilla, bonobo dot for each system dot out. So this is a consumer. It will print 3 of them, as you can see that. All right. So what happens if you want to use with infinite? So if you use like infinite dot for each and then system dot out, a method reference, so we already have used a stream over here, so it will give an error. If you really want to check, we can do like this. And we have to terminate, otherwise it will go on and on. Okay, so if I make a stream of integer s and try to make a stream of one element, can I use a for each loop which I use in a collection? So you can see that it gives a compiler error. The for each not applicable to java.util.stream.streams, because stream cannot be used as the source in a for each loop to run, because they do not implement the iterable interface. So each collection implement the iterable interface. We can use for each loop, but we cannot use with the stream. Next is reduce. So what happens if you use reduce with infinite stream? It doesn't terminate. Return values varies. I'll explain you now. And reduction, yes, it does look at each element in the stream and return a single value. The reduce has 3 overloaded methods. The first one has identity and binary operation. Next, reduce. Reduce method combines a stream into a single object. It doesn't terminate when we use with infinite stream. Return values varies and it is reduction. So there are 3 overloaded methods of reduce: terminal operation, terminal method. So the first one has identity and binary operation, which is accumulator. The second one only accumulator. The third one identity, accumulator, and combiner. What is identity? Identity is the initial value of the reduction, and accumulator is a combine the result with the current value in the stream. This is the initial value. Whatsoever the current value, it starts combining. And combiner is used to combine any intermediate totals. So we will see the 3 of these examples. Reduce. So I would like to explain through a simple example. In Java 7, we used to create array like this. I've created another string result and used the for each loop. And what I have done, I have added the string into the result and then print out result. So what is happening over here? It is getting each string, combining and storing in the result variable. So at the end, this is a combined string. If I would like to do in Java 8, so how do I do? I'm going to use the first version of reduce method. String equals to string dot of w o l f and dot reduce. The first one, we use the identity, which is the initial value, and then the binary operator, how we use these two values, we are going to combine them. Now check that. Yes, the same result. Okay, now here try to use a method reference. So it gives the same result. Let's use with the integer. String dot of 3 5 6 dot reduce. You need the initial value and then you need accumulator. So here, so it will multiply 3 multiplied by 5 multiplied by 6. So it has given 90, right? Now I'm gonna use the second version, which doesn't have identity, and remember that it returns optional. So if I use the second method, so it gives the value optional 90 rather than 90. All right. Let's use with the stream.empty dot reduce AB and A multiplied by B dot if present system dot out println. But the problem over here, this multiplication operator applies on integer. So for that, we can specify the type here. Okay, that this is a stream of integers. And when we run this one, there will be no output. All right. So now make a stream of one element and see how it works. So it gives 3. And we already have seen that if we do with the 3 elements, it gives the product of 3 elements. Okay. What happened with the 3 elements? So it gives the product of 3 elements. Okay. All right. The third one, which has everything, integer reduce 1 equals to stream dot off and then W O L F and then reduce initial value. We do I with string whatsoever the value of I, we add with the length of the string, and AB, these two, and we combine them. Okay, and S out, reduce 1. All right. So just run this one and see what happens. It gives a 5. Okay. Next, collect. It doesn't terminate with infinite streams. Return type varies, and it is a reduction. So get the data out of the stream and put into another form. So there are two overloaded methods: supplier, accumulator, combiner, and the one only with collector. It is a mutable reduction method. It is more efficient than a regular reduction because we can use the same mutable object while accumulating. So let's see that. Collect, so I'm gonna make a string builder object word dot of wolf dot collect, and the first one is supplier. So I'm gonna put a new object. The another one is accumulator. So I'm gonna do a string builder and the reference of append method. And the third one is combiner, and I'm going to use the same one, string builder and append. So it is very efficient because we have used immutable object rather than immutable. Now I would like to print and it gives the combined result wolf. So the collect, we use a mutable object which is faster than immutable object which we used in reduction. In this logic, accumulator and combiner are same. Now I've used the tree set. In the tree set, all of these strings will be in sorted fashion. And if I run this one, so it has displayed everything in sorted fashion. I can write all of the above similarly like this to serve the same purpose, right? And if I run, yeah, so it's doing the same. Okay, and instead of using the tree set, what would if I use set? So it will return the unsorted set, because set is not sorted. Tree set is a sorted set. So you can see that. Okay. Intermediate operation. It produces a stream as its result. It can also deal with an infinite stream simply by returning another infinite string. There are many important intermediate operations. I will go over some of them. The first one is filter. It takes predicate and return a stream with elements that matches a given expression. Let's see that. I have created a class intermediate operation in the package intermediate. First, I will show you how to use a filter method. I'm going to create a stream of string contains string monkey, gorilla, and bonobo. Now I need to pass each string in the filter method and check is it start from M or not. If it does, then pass on further. I'm going to use for each method and pass the method reference of println. Run this class and it will show only monkey. All right. Distinct method. It returns a stream with duplicate value removed. So we have a stream of string which has multiple duplicate value, and we are going to use distinct method which removes all duplication. And now we can see the result. So it prints duck and goose. Okay. Next is limit and skip. Both of these methods we mostly use with infinite stream, and they make infinite stream to finite stream. We pass the maximum size to a limit function. It returns the stream of those number of elements. Skip, it skips the element and return the stream. Let's see that. I'm going to do stream.iterate, creating infinite stream, pass a seed and add 1 into the previous value, skip the first 5 and then get the next 2 and then print all of them. So it skipped the first 5 and print 6 and 7. All right. Next is map. Map we use to transform elements of a stream as per function. So this map is transform one type to another type. It is completely different the map which you have studied in the collection, so which stores a key value pair. The main difference is that map starts from capital M, this map is small m. This is a method, and it normally used to transform one type to another type. It's intermediate, it returns the stream. Okay, let's see that. So for instance, we have a stream of integers, and then we are going to get the length and print, get the length and print each. So it's going to be 6, 7 and 6, as you can see that 6, 7 and 6. So we have converted the string to integer. Next is flat map. Flat map, normally we used to remove empty elements from a stream and combine a stream of list. It removes the unnecessary layer. Very useful function. So to explain flat map, I would like to make a list of string, call it 0, and say arrays dot as list completely empty. Then I'm gonna create a variable 1 with only one element, bow, no bow. So this is a good thing in IntelliJ. It gives you a hint what is the type of this variable. Now I'm gonna make variable 2 same like as above, and I'm gonna make two string, mama gorilla and baby gorilla, and then what I'm going to do, say stream dot off and put these three lists, stream dot off and put three list 0, 1, 2, and dot flat map list stream, and then print it. So what will happen, we are passing list of string, it making a stream of list of string, and flat map, it's converting list of stream of list of string to stream of string. So to see this one in a more clearer way, I extract out variable, put animal here, and then Also Control Alt V, extract out variable animal new animals. So you can clearly see that. So this is a stream of list of string, and what the flat map has done, flat map has changed the stream of list of string to stream of string. So it is very important function. Okay. Next, sorted. There are two overloaded methods. One use natural order, another use comparator. So the second one returns a stream with the sorted elements, and it collects all the elements as they come in and sort them all at once. Let's see that. If I have a stream of string brown, beer, and we want to sort them, so beer comes first and then the brown. Okay, now I would like to use comparator, and I put here brown, beer, and here I put grizzly. Here I can use comparator dot reverse order. So what would happen? So it will print grizzly first and then the brown beer. Grizzly first and then the brown beer, because I put the reverse order. What would, if I would like to use a method reference instead of method call, so compiler will give me an error. What is the reason behind it? Sorted needs comparator, and comparator has one abstract method, which is compare. It requires 2 argument return integer, whereas reserve order doesn't have any argument, it returns comparator. That's why we cannot use method reference here. Okay. Next is peek. Peek is pretty much same like as for each, but it returns the string. So we can use this one as intermediate function. You can see the for each, it iterates over elements of string, and we pass consumer. Same thing in peek, we pass consumer. It performs a stream operation without actually changing the stream. It is useful for seeing how a stream pipeline works behind the scene. So let's see that. So let's create a variable count, stream.off black bear, brown bear, and grizzly. Now I use filter, and in filter I just need the string starts with G and count this one and print it. So it gives 1. But if I would like to see that what is coming after the filter, so same like as for each, I can pass the reference of println and it gives me grizzly is coming towards the terminal function. There are some cautions for the peek method. So let's do without peek. I have created array list of numbers and array list of letters. Now I'm gonna add 1 in it, and in letters I'm gonna add A. Then create a stream of array list and use a map to transform list to size and use for each to check the size of each list. So you can see that the first list has 1 element, second list has 1 element, and the elements are already there inside. So now use peek. This should be here. And here you try to remove the first element from the list. So peak doesn't prevent us from writing bad peak code. So it updates variable and result of stream. So now you can see that it removed and the size changed to 0 and there is nothing inside the list. So make sure whenever you use the peak, try not to change any code, and Java doesn't prevent us from writing bad peak code. Okay. So now I would like to put everything together. I have made one class pipeline in the stream package, and there is a main method in there. So in this pipeline class, I am putting together everything. So in Java 7, we want to get the first two names alphabetically. We need first two names alphabetically. Those are 4 character long. So how could we do that? In Java 7, we have to create a list of names. Let's put some name, Toby, Anna, Leroy, and Alex. What we need to do, we need to create an empty array list and then we need to iterate over the list of string, and if the length of string equals to 4, then we will add into an empty. Alright, that's what you used to do. And it says must be alphabetically, so we need to sort them. For sorting, we need to do collection.sort, and then we need to put this an array inside this one. I need the iterator. I need only 2. So iterator of string equals to filtered dot iterator, and then I need only 2. So has next actually put the pointer to the next available, and next actually gives the element. So it prints out the first element and then this prints out the second element. So this is the one we used to do in Java 7. So we can see there is a quite a lot of a code to get the first two names alphabetically. Those are 4-character longs. So what we need to do in Java now 8, in Java 8, I just need to do list.stream dot filter. Filter is like a if statement. So is a predicate of a string. So we are passing a string. So n dot length, if it is equals to 4, then pass through, and what need to do, sort them, and then we need only 2, limit only 2, and then what need to do, need to print them. And here we pass the method reference of println. So what the filter does, filter actually pass 3 of them, Toby, Anna, and Alex. All right, Toby, Anna, and Alex. When we sort them, so it will become Alex, Anna, and Toby. Alex, Anna, and Toby. And when we limit them to, so it only pass Alex and Anna. Okay. So if you want to see this one, let's comment out the sorted and limit and see that. So it's say Toby, Anna, and Alex. All right. Now just sort them and see that what it prints now. Alex, Anna, and Toby, right? And then limit, it will be Alex and Anna. Alex and Anna. Okay. So we comment out each and see that how it works. So in the Java 8, you can see that it is quite short, and we just tell what we need, not how do we need, which is way faster. Let's see some infinite streams. So stream dot generate the stream of string, and then filter them, sort them, and print them. So what would happen over here? So the length is 4, it pass each, and they are infinite strings. Those lengths are 4, so it will hang. we need to kill the as I have done here. Okay. So what about if I change the order? Before sorting, I said only two I need to sort. And say else, right? So it works. What about a string which is more than 4 characters? So none of them equal to 4 and none of them pass through the filter, so it hangs. And we have to kill the program. Okay. One thing you need to know that you can chain 2 pipelines together. Chain 2 pipeline together. So for instance, if you have a variable count, just make a stream of string of 2 elements, goldfish and finch. Use filter like if statement. If the length is more than 5, then it passes through, and then collect them in the list. So it returns the list, and as you know that you can convert the list into the stream by stream method, and then you can call the count to count. So yes, I could do without the collect and stream, but I wanted to show you that from stream of string to list I have made, and then I counted through it. Then I change back from list of string to stream, and then I counted. So there are 2 streams together, and there is only one whose length more than 5, and it gives the answer. Let's copy this one, and now I would like to extract this one. Control Alt V, so this occurrence only, and I can put the variable name helper, and I can use over here count equals to helper. So what I have done, I'm trying to show you the way I had joined before, and now I have detach. So either or is good. Okay, and it gives the same answer 1. All right. Now use peaking techniques behind the scene. So I am going to make an infinite stream of integers, and I just need first 5, then I need to pass to the filter method those are not even and then print them. So it will print 1, 3 and 5. 1, 3 and 5. The reason why, so it cannot pass 2 because it's an even number. Yeah. Remainder is 0, not 1, and same thing with the 4. What would now you use a peak method, and peak has same consumer here. So you can see here, first it pass 1 and 1 come down here and prints 1, so it gives 1, 1. Then it pass 2, 2 cannot print 2 because has not passed through the filter. Then 3, yes, 3 can pass and then print the 3. And then 4 cannot, and then 5, yes, 5 can pass, and 5 over here. That's why it is 1, 1, 2, 3, 4, 5, and I have shown you where it has printed to give you a complete output like this. Okay. So what would if you change the order? So it passed a number and first 5 going to print 1, 3, 5, 7, 9. So 1, 3, 5, 7, 9. Okay. It was limiting 5, and after filter it becomes only 3, 1, 3, 5, and here is filtering everything and then sending only 5. Okay. So you change the order, change the output. So now the same thing, if you put the peak in here to see how it is. So how it would be. So the first one pass is 1, and then print here is 1 as well. So there 2 times 1, and then pass 3. 2 cannot pass because remainder is 0, not 1. So here also twice it print 3, and then twice it print 5. 4 cannot because remainder is 0. 6 cannot, remainder is 0, so 7 here and 7 here, and then 9 and then 9. So it can only pass 5. So you will see that in duplication 1, 1, 3, 3, 5, 5, 7, 7, 9. Primitive streams. Up until now, all the streams we have created use the stream class with generic type, like stream string, stream integer. Java actually includes other stream classes beside stream that you can use to work with uh, select primitives. Int stream used for the primitive types int, short, byte, and char. Long stream used for primitive type long. Double stream used for the primitive type double and float. I have created a class myIntStream in the package stream.primitive. If we want to calculate the sum of a number in a finite stream, how do we do? As I have shown you, we can use a reduce method. We give the start value and we can pass a function interface. So what it does actually, so the first is 0, so s is a seed, the starting value, and n is the first value, so 0 plus 1, it gives 1, and then afterwards the sum will come over here, and 1 and then 2, it becomes 3, and then 3 comes over here, and then 3, it becomes 6. Let's run this program and see that how it works. So it gives 6. Alternatively, we can do stream dot map to int x dot sum. So what it does, so stream dot map to int return the int stream, and int stream has a function dot sum. So I will extract out this stream dot map to int by a variable, control alt v. So let's give the name as my int stream. This sum function is very handy. Now I'm going to create int stream, and int stream has a function average, control alt v and avg, and s out avg dot get as double. So what's going on over here? As this seems like a nice convenience, but not terribly important. Now think about how you would compute an average. You need to divide the sum by the number of elements. The problem is that the stream allow only one pass. So Java recognizes that calculating an average is a common thing to do, and it provides a method to calculate the average on the stream classes for primitive. Okay, so let's run this one, and it's giving 2. Okay, 6 divided by 3 gives you 2. So what about if I comment out this one? What about if I comment out this one and then run the program? So the same answer will come, but it says optional double. All right, so gut as a double, extract the value out. All right, so as we have seen, method average, which returns the optional double, it gives the arithmetic mean of elements. It is in each primitive stream class. There is a very useful method, boxed. If we want to convert the primitive stream into a stream, we use box method. And each of them have a maximum function which gives the maximum element of a stream. Minimum gives the minimum element of stream. Range, it returns the primitive stream from first element to the second element, in which first is included and the last one is excluded. And close range, all the elements from the first parameter to the last parameters are included. Sum, as you have seen, it returns the sum of elements. It's in the 3 of them. And summary statistics, it returns an object containing numerous stream statistics such as average, min, and max. I have created a class myDoubleStream in stream.primitive package. So I can create an empty stream. I can create finite stream. And if we want to display the value, we use for each and pass the method reference of println. So now I'm going to pass more than one double values. We can create infinite stream. So double stream dot generate. Maths has a function random. We're gonna pass a reference of it, and then it's a infinite stream, so I need to assign limit, and it will print out 3 values. And we can also use iterate method. We can pass the seed value, which is the starting one, and whatsoever the value comes, we divide it by 2. And same like fraction dot limit up to 3, and then for each system dot out, and then okay. So now let's print. So the first one is empty, it didn't print anything. Second one, print 3.142. All of 3 of these values printed out over here. Random values are here. This one starting from 0.5 and then divide by 2.25 and then 0.125. Okay. All right. Let's come back to my int stream class. Control tab, and I will create some infinite stream. So how do we do that? We have a random class, and in int stream in random class we have ints function which returns the int stream. Control Alt V, and we can say ints and then ints dot limit 3 dot for each, and we will pass the method reference of println method. Okay, so it will print similarly the 3 random numbers through the int string. There are other ways as well. if I say int stream dot iterate, same like as I have done in the double class, 1 is a starting value which we say seed, and whatsoever the result we add, and dot, there is a function limit and we need only 5 values. Okay, and I am going to introduce the variable name count, and I can do similarly count dot for each, and then system dot out dot and println. Okay, so this one gives 5 random values. Okay, as we discussed that there are other methods. There is one method is called as range, and I put 1 and 6, and in this range, if we try to print out, it will print from 1 to 5. 6 is not included, so I say range dot okay, and there's also a function called as range closed. Okay, if I put 1 and 5, it will print 1 and 5, so both are inclusive. So ranged closed and range closed. Okay, so let's run this program. So you can see that the first 3 random values are here, and then these are the values, and we need only 5 starting from 1 and adding 1 in the previous one, so 1 2 3 4 5, and this is 1 to 6, it's only 1 to 5, and the next one is 1 to 5, is 1 to 5. So here you can see that the 6 is not included. Okay, all right. Mapping stream. Mapping stream means transforming stream from one type to another type. On this slide, we have a stream class and 3 primitive stream classes: int stream, long stream, double stream. Number 1, each class has map function which returns own type. You can see that. The argument of map function in the stream class is function, and argument in the primitive stream map function is primitive unary operator like int unary operator, long unary operator, double unary operator. Number 2, in stream class we have function map to primitive to convert stream to primitive type. So whatsoever after the 2 primitive type, it would return the same primitive stream, which is self-explanatory. You can find out these 3 functions in primitive as well, but map to int you will not find out in int stream. You have map function, and same thing, map to long you won't find long stream, and map to double not in double stream, rest are there. And if you want to get stream from primitive, you use map to object. Number 3, if you have map to int function in the stream class, the argument will be to int function, not stream to int function. And if you have map to long, the argument will be to long function. It will not be stream to long function. Same thing with the double. However, with the primitive, if you use map to long in int stream, it will be int to long function. So you have to add the primitive before to, but you will not do in the stream. Okay. So these are the three key points. If you remember that, you can easily remember the chart. Let's see some examples. I have created a class mapping. Stream to primitive stream. So I'm gonna create a stream of integer Control Alt V, and I'm going to create a variable object stream. I am going to use the stream of a string to convert to int stream, and the function is map to int. The argument is toInt function. If I go to toInt function, there is a method called as apply as int, which gets a type as an input and returns integer. So S is, as we know, it is a string, and string has a method length. Control Alt V, and it's going to be int stream. Okay, so I have changed, you can see that, the stream to int stream by using a function called as map to int. Okay, now I am going to do the reversal, primitive stream to stream, and I'm going to create a method, private static stream of integer mapping int stream stream, and what I'm going to do, I'm going to use the int stream function map to object. So what it does, actually it converts back to stream. Okay, so it will convert int stream back to stream. There's one more way to perform the same operation, and that function is box function. It auto boxes each primitive to corresponding wrapper object. So the function name is boxing, and I'm gonna say it is a private function, and stream of integer I'm again going to use int stream and return stream dot boxed. So you can see that you can both the arguments and return types are same. You can use map to object, or you can use a box function from a primitive stream to stream, and box is in every primitive stream. Okay, flat map. The flat map method exists on a primitive stream as well. It works the same way as on a regular stream, except the method name is different. So if you have a list of stream and convert into a single stream, as we have seen that we use flat map function. If we convert into the double stream, so we add two double for int, two int for long, two long. Okay, let's see that. Flat map to xxx. So I am going to create integer list and I'm gonna do integer list has a function stream. Now every collection has a stream function which converts the collection into the stream, and then dot flat map. So we have flat map to double, int, long. I'm going to use flat map to int, so we need to convert this stream to int stream. How we do? Int stream dot off and x, so it will convert every value of a stream into int stream. So the same thing we can do with the double and long stream. So we can say that ints, if we have integer list dot stream dot flat map to double, and it's gonna be double stream dot off x, control alt v, and I'm gonna say doubles. Same thing I can do with the long. Flat map to long and x, long stream dot off x, control alt v, and I'm gonna say longs. Okay, so you can see that so we use a flat map function to convert a list of a stream to a primitive stream. Okay, next, optional with primitive streams. So we can use optional with the primitive streams. In optional double class we have a method get as a double. In optional int we have a method get as int. In optional long we have a method get as long. The same optional double class we have or else get. In augment type we supply double supplier. In optional int we supply the parameter as int supplier, and for optional long class or else get we supply the parameter type long supply. In all these classes have max and min, and the return type is optional double for the max and min, optional int for the max and min in optional int class, optional long max and min in optional long class. All these three classes have a sum, and return type is primitive type. For optional double is double, optional int is int, optional long is long. All three classes have average function. Optional double, optional int also gives optional double, optional long also give optional double for average. So let's see that. I have created a class using optional. So I use a method range closed, and then stream dot average. So what it does, it gives the average of all the number from 1 to 10. So this is a better way to calculate the average of the values in primitive string. And return type is optional double. Okay, so optional has a method if present. If there is a value, then print the value. So I'm gonna pass a method reference of println method. Run this class and it gives 5.5. Similarly, I can do dot get as double, which gives the same result. Or I can do optional dot or else get double dot n a n. So all of them going to return 5.5. Okay, now I will create an infinite stream of double stream. So double stream dot generate, and it will create an infinite stream of pi value, which is 3.142. So double stream has a function called as min max. I can use the min function, which returns optional double. This code will run indefinitely. As you can see that. And the reason is all these infinite series values are equal and we do not have any minimum value. Code can run indefinitely in primitive stream as well. I have created a class myLongStream. In that class, I am creating a long stream of two integers, and it has a function sum which returns the primitive type of a stream, and here we can print the sum. So sum method doesn't return an optional, it returns primitive type. So 5 plus 10, 15, and it gives 15. Okay. Summarizing statistics. I have created a class summarizing statistics to explain the concept. Let's create a int stream of 10 numbers, and pass into a method max. So in this method I am going to call a max function of int stream which returns optional int. And we will throw an exception if it won't find out anything. Okay. So the maximum value is 10. What would if I send the empty? So it will throw a runtime exception. Okay. But now we want to change the method to take an int stream and return a range. The range is the minimum value subtracted from the maximum value. So both min and max are terminal operations, which means that they can use up the stream when they are run. We cannot run two terminal operations against the same stream. So for that, we have a way to solve this problem through summary statistics. Okay. So summary statistics solve the problem of using multiple terminal operations and get the result. What is the meaning of statistic? A number that was calculated from data. Okay, so it has get min, get max, get average, get sum, get count methods, and we're going to use all of them. So let's make a function range, and it returns int. Int summary statistics. So in int stream there is a method called as summary statistics, which returns an object of int summary statistics. And if I say if the get count equals to 0, then throw exception, and otherwise return max minus min, as we have discussed. Okay, so let's run this one and see that. So we can see that 10 minus 1 is 9. All right, and if it would be 0, it returns if it would be 0, then it throw an exception. All right, as we have seen up for empty. If I would like to get the average of all of them, how can I do that? So average methods return double. I'm going to use the same way and return dot get return stats dot get average. Okay, so it's gonna add all the numbers and divide by 10. So return is 5.5. Okay, as we have discussed that there is a Getsum method and get count. So if there is an empty string and I pass in the count method so it will return 0 instead of empty optional. Okay, it returns the 0. The same thing with the sum method. So Getsum method also returns 0 if it is empty instead of empty optional. All right. So we have seen all these methods. Common functional interface for primitive. So these functional interfaces have a primitive wrapper class in the start. So double supplier, what it means that return type is double, and after the get method we put as double. You know the supplier has a method get, so here single abstract method have become as double. The same thing with int supplier and long supplier. Double consumer means argument is primitive double and consumer consumes, so method name remains same and return type is void. Same thing with the int consumer and long consumer. Double predicate, the same thing, input is primitive double, return type boolean, the same method name test. Double predicate means the input is double, return type is boolean, and method name is same. Same thing with int predicate and long predicate. Double function means input is double and return type is the type mentioned with the function, and the method name is same. Same thing with int function and long function. Double unary operator, input and output is double primitive. Same thing with integer and long. Double binary operator means two inputs are double and return type is double. In binary operator means two input are integer and output is int. Long binary operator, two inputs are long and output is long. Okay. So for boolean we have only boolean supplier. Okay. So let's see that. I have created a class my boolean interface. So I'm going to create a boolean supplier reference. And I'm going to say B1. Okay. The second way, maths dot random, as you know, if the value is more than 0.5 then return. So boolean supplier B2. So boolean doesn't have boolean function, boolean consumer, so boolean has only boolean supplier. So b1 dot get as boolean, and same thing b2 dot get as boolean. I'm going to run this class. So both results are true. The first one is always true. The second one, if the value of the math.random is more than 5, it gives true. Run one more time. Same. And this time is false because math.random this time is less than 0.5. Next, primitive specific functional interface. So these are two functional interface. You can see that it says two double function. So input is the type we mentioned, and return type is double. Same thing with integer and long. Two double by functions. So input would be the two types we mentioned, and the return type is double. As you can see that with apply, it extended to as double, as int, as long. Similarly with these ones. So double to int is self-explanatory functions. So input is double, output is int, and double to long, int to double, int to long, long to double, long to int is very self-explanatory. And whatsoever we require after the two come over here as that primitive. So there are also three: object double consumer. So consumer means this consumes, it doesn't give anything, so its return type is void. And double, it means that its input is double, and type and double. That's what there is obj. That's why it is obj. Obj int consumer, so type and integer. Obj long consumer, type and long. I have created a class myFunctionInterface, and I'm going to create a double value, and now I'm going to create a function interface double to int function, and this one I gonna call f1. And how I call this method? Apply as int. So I told you after the two come as that primitive, and here is double. So here you can see control P, the argument is double. Now I can create two int function, and this one I'm going to say f2. Okay, and I say f2 dot as apply as int, but here the argument is object. If I put the double, it will auto box into the double class, and it will run. Okay, so I have explained how we have used the primitive to int and two primitive functions. Okay, so please try the rest of them. I hope you like my video. Stay tuned, and wish you best of luck for your exam. Thank you.